Okay, so the next part, really what got cut off from my ion part, is the grams to moles. Okay, so we can go back and forth between grams and moles by using the molar mass. So the way that we go grams to moles is the molar mass. Okay, the molar mass is measured in units of gram per 1 mole, because that's what the word means. So we have molar, so we have 1 mole, mass, which is grams, so it's just grams per mole. Okay, so the way that you find the molar mass from an element, so molar mass just from an element. You go to the periodic table and you find the element. So if we were looking for carbon, we would go to carbon and we would find its square and we would see C. And then ours say carbon underneath, and then it has 12.011. Okay, so this is our mass. It's our atomic mass, but it is also our molar mass. So for carbon, the molar mass of that would be 12 grams per mole. Okay, so the molar mass is not a 1 unit definition. It has 2 units. It's a gram per mole. So it's technically the molar mass can be used as a conversion factor. Okay, and it is individual per element. So if we need to do this of a compound, so molar mass for a compound, you're going to take each piece of the compound and break it apart. So the one that we did in class was 10,2 hydroxide. Okay, so if you go in the periodic table, you don't see 10,2 hydroxide, but you do see 10, and you do see oxygen, and you see hydrogen. So let me rewrite this in different colors. Okay, so that was a whole lot of extra work, but it doesn't matter. So you break it into the pieces. So you say 10 and oxygen and hydrogen, okay? And so for each, you want to find the amount. So we're looking at how many we have of each. So I have 110, I have 2 oxygens, and this 2 also applies to hydrogen, so I have 2 hydrogens. You multiply that by the mass of each element. So if you go on the periodic table for 10, that square, it's SN, and then it's 118.71, I believe. So that means that the mass is roughly 119. If you look up oxygen, it's O, and you have 15.999, so that's roughly 16. And for hydrogen, you find H, and it is 1.008. So we're just going to use 1. So once you have the mass of all of these, you can solve. And so 1 times 119 is 119. 2 times 16 is 32. And 2 times 1 is 2. And so once you have them all, you can add them all up. And so that adds up to 153, I think, grams per 1 mole. So what I'm seeing a lot of people doing is they'll write 153, but they forget to put the unit with it. Okay, you have to put the unit because that's what a molar mass is. So this is the molar mass of 10,2 hydroxide. So the molar mass of 10,2 hydroxide is 153 grams per 1 mole. Okay, so we can write that in a problem as 153 grams per 1 mole. Or since this is a conversion factor, we can flip the equation and we can write 1 mole over 153 grams. Okay, so we just have to pick which one we want to use. So let's work this problem. So this is how much does 2.3 moles of water weigh? So the first thing of every equation or of every problem is we're going to find our given. So our given is 2.3 moles of water. So 2.3 moles H2O. Okay, and we are asked for how much it weighs. Okay, weight is measured in grams, so we're asked for how many grams of water. So we need a conversion factor to go from given to goal. So we are going mole to gram, so this would be the molar mass. That's what we're going to use. So we don't know the molar mass of water because water is a compound. So we have to break it apart and figure it out. So H2O, I take my two pieces and I break it apart. I have 2 hydrogens and 1 oxygen. The mass of hydrogen is 1 and the mass of oxygen is 16. So that's 2 plus 16. So the overall molar mass of water is 18 grams per mole. So the molar mass is 18 grams per mole. Okay? So once we know that, we can start our problem. So we're always going to start with what we're given. So you're going to start with 2.3 moles of water. Okay? And you are always going to multiply given by a conversion factor. Okay? Until we get to goal. So we may have to keep using conversion factors until we get to goal. So we have to eventually equal goal. Okay? Let me get this out of the way now that we've found it. It's very much in the way. Okay? So I'm still at given, so I need to multiply my given by a conversion factor. Okay, so I'm going to start writing it in bracket form so that we can get used to that. So when I write the vertical line, that means multiply, and the horizontal line means divide. So if I have mole on top right here, I want to put mole on the bottom of the next bracket. So I'm going to put 1 mole of H2O. And I know right here that 1 mole of H2O equals 18 grams. So I can say 1 mole here equals 18 grams of water. Okay? And so that means that the mole of H2O and mole of H2O cancels. And the only thing I'm left with grams is grams of water, which is my goal. So I have grams of H2O. So then I can be done with my bracket, and I can just solve for my answer, grams of water. So in my calculator, I would put 2.3 times 18. Sorry, I keep messing up. Okay, and that's 41.4 grams of water. Okay, so the next problem is going the opposite direction. So it says how many moles of carbon dioxide are there in 32 grams of carbon dioxide? So we start with what we're given, which is the number. So we have 32 grams of CO2. We are asked for how many moles of CO2, so question mark, moles CO2. So we have to find a conversion factor to go from grams to moles. The conversion for that is molar mass of CO2. Okay? So 1 mole of CO2 equals how many grams? So we have to solve for that. So I have CO2, so I have 1 carbon, and I have 2 oxygens. So I multiply how many I have by my mass. Carbon is 12, oxygen is 16. So I have 1 times 12 is 12, 2 times 16 is 32. Add these together and you get 44 grams per mole. Okay, so 1 mole of carbon dioxide is equal to 44 grams. So I can use this conversion factor as 1 mole over 44 grams, or I can flip it and say 44 grams over 1 mole. Okay? So again, anytime we are done with all the stuff that we know, we have to start with what we're given. So we start with 32 grams of CO2, and we're going to multiply it by a conversion factor. If the grams is on top, it needs to go on bottom of the next bracket. So I'm going to use a conversion factor. So I'm going to use this one right here. Okay? So I know that 44 grams is equal to 1 mole of CO2. Okay, so that cancels out grams of CO2 with grams of CO2, and that leaves me with mole, and mole was my goal. Okay, so then I just solve. So in my calculator, my calculator, I would say 32 divided by 44. And I get 0.727. So this is my answer. Okay, so this is how to do grams to moles or moles to grams. You're always going to use the molar mass. And please remember that the molar mass can be written as grams on top or moles on top, but that the number goes with gram and 1 goes with mole. So you can flip this however which way you want it, but the number stays with gram and 1 stays with mole. Also, anytime you write molar mass, please remember that it's grams per mole, not just grams.